there are three types of energy. The three types are kinetic, potential, and field. These three types have several other subcategories that we call forms of energy. So there are many forms of energy, and some of those forms are heat, which we call thermal, electromagnetic, gravity, sound, mechanical, electrical, chemical, nuclear, elastic. Those are the main types of energy. Now there's several more that we could list here that I haven't said, but those are the main ones. And within each type and form of energy, we can break this down further. So first off, let's talk about the most common form of energy that you guys tend to know about, and that's kinetic. Kinetic energy is a type, it's not a form. Okay, when we talk about energy, we want to know forms of each one. And so kinetic is always energy of motion. And we can solve and we can figure out how much kinetic energy anything has by knowing this formula, 1/2 mv squared. Now I like to put parentheses in here, and you'll see why that is in another video. This stands for mass, and it's measured in kilograms. That is velocity, and it's measured in meters per second. These are units, these are variables. Kinetic energy has two categories within it. You've got micro, you've got macro. And as you can guess, micro kind of sounds like microscope. So these are forms of energy that you cannot see. Okay, these are one where you got all these little particles moving around that you just can't see. And the best known one is thermal. Thermal, you have all these things, all these particles that are moving around, and they give you a temperature. Okay, it is a measurement of energy. So anything that has temperature, you're getting a measurement of how much energy it has. The other micro one that we can't see is electrical. Electrical energy is moving electrons through things like video game wires and circuit boards in your phone and everything like that. And so they all move in one direction. And when they're only going to move in one direction, you can put a half arrow there. And we denote electrons with these symbols here. So they're all moving in one direction to give us our energy in the form of electrical. The last form of micro energy is sound. You're hearing my voice now. You're not having to be plugged in. Sound travels over a distance, but it's moving particles. Okay, it is energy that is transferred as waves. And we're not going to talk a great deal about waves this year, but waves or vibrations is one great way to move energy from one location to another. Particles bouncing off other particles so that you can hear them. So that's all of the micro. Now we're going to work on macro. Macro is energy that you can see. It's bigger. Okay, they tend to have some moving parts here, like this little saw blade here. You can tell it's moving, that it has energy when it starts to move. And so it is be like mechanical energy. And so, you've got pickup trucks, they all have mechanical energy. This is the one most people think of. They have mechanical, but you know what? Even little Johnny here that's running around can have energy. I have mechanical energy because he's moving. It's energy of motion. Alright, the next category we want to really hit on is field energy. Field energy is kind of special. It's the one that most people don't hit very often in middle school. Field energy is energy at a distance. So it doesn't have to touch, but it still has energy. One that we worry about most is gravitational. Gravitational energy affects things because it's constantly pulling it down until it eventually hits ground. And anything that in this earth is affected by gravity, and therefore it is affected by field energy. Second big one that we want to talk about is sound. Notice how sound is also in kinetic. Well, sound acts at a distance because your ear doesn't have to be right next to the person's mouth to hear. Acts at a distance. Okay, and then the last one that we really want to focus on, all you guys know, is electromagnetic. And electromagnetic is the same thing as light. Okay, and we don't want to say light because this includes more than light. And you don't have to be right up on a light bulb to see, to see its effect. You can see it from a distance, and therefore it makes it a field energy. The third type of energy is potential. And potential energy is energy that is stored. So I'm just going to draw a little box here to represent that. That is stored energy. It's energy that's not going anywhere until you tell it to. And we can calculate potential energy. So just like kinetic, we can also calculate potential. So we call this E sub P is equal to mgh, where m is equal to mass. And again, it's in kilograms. It's always in kilograms. G is equal to 9.8 meters per second squared. This is always. And H is equal to height. And that is always in meters. Okay? And if we remember that, we can always calculate how much potential energy we have and how much energy we lose from kinetic. So what are some forms of energy associated with potential? The very first one we want to talk about, we've already mentioned it before, is gravitational. Gravitational energy is energy of position, okay? We commonly call this GPE, gravitational potential energy, okay? Gravitational potential energy is everything has the ability to fall. Everything has the ability to fall. Therefore, it has gravitational potential. Another type is chemical. Chemical energy is energy stored in the bonds. Now, I want you to take a look at this because it says it's stored in the bonds of molecules, and that's very similar to the one I'm about to talk about, which is nuclear. Nuclear energy is energy that is stored in the nucleus. It's stored in the nucleus versus stored in the bonds of molecules. So here, like we have an atom here, and like this. So we've got one right here would be right where the bonds are. Whereas in nuclear, you've got an atom, and you're splitting it right down the middle to get the energy. So what we have, once we put this together, we have a nice little chart. We have energy. And so energy, kinetic is movement, field is energy at a distance, potential is stored, energy is the ability to create change. And this ability to create change is governed by two key laws. Okay? These two key laws determine what's going to work and what's not. So the very first law is the law of conservation of energy. And it states that energy cannot be created or destroyed. The second law is the second law of thermodynamics. And the second law of thermodynamics says that energy can only be transferred or transformed. Between objects, and some of it is lost. This lost energy right here is what we call entropy. And it can only take two forms. Okay, and the two forms it can take is thermal and sound. Now I want to go back a step. So I just remembered I forgot something here. So back up here on nuclear energy, some of you guys are probably familiar with the Hulk, and the Incredible Hulk exposed himself to some nuclear energy. Now he didn't quite expose himself to like a nuclear reactor, but he came pretty close. And he exposed himself with gamma rays, which are radiation, and they are very, very strong. These gamma rays we use in X-rays. So they won't make you the Incredible Hulk, but they can be used to save your life in X-rays, MRIs, and as such. And as you come down this way, you get weaker ones. And so this is alpha. These are beta in the middle. Alpha waves are really weak. We use them in smoke detectors. Beta waves we use to treat bone cancer and other kinds of cancers. All right. So I hope this video here has helped to has enlightened you just a little bit, made you think a little bit about energy and the things that you know and don't know. And feel free to come back to this video and speed it up and slow it down as you need. Alright? Have a good day, guys.